Welcome you all back to my YouTube channel, and if you are new to this YouTube channel, consider subscribing so that each time I upload a new content you get to be notified. And in this lesson I want to talk about chemical bonding. I want to make this topic very simple so that we understand. So we are talking about chemical bonding. We are going to do this with exam questions. We are going to practice through exam questions as examples. So now, what is a chemical bonding? This video is good for the grade 10 to 12, even the GCEs. This video can really help you even as you prepare for your exams. So, what is a chemical bonding? I wrote down this definition of a chemical bonding so that we build from here. A chemical bonding, this is a chemical combination of two or more atoms. So whenever we are talking about a chemical bonding, this is just a chemical combination of two or more atoms. So when two or more atoms combine together, they form what we call a bond. They are going to form a bond. Have you seen? So when two or more atoms combine together, they form a bond. So now, what is a bond? A bond, it is just a force of attraction. It is a what? A force of attraction. A bond is just a force of attraction. So you know that bonding is a chemical combination of two or more atoms. So when they combine together, they form what we call a bond. And a bond is a force of attraction between atoms. So atoms are held together by these forces of attraction. Have you seen? Atoms are held together by these forces of attraction. So one thing you need to understand about chemical bonding is that why do atoms bond? You need to have this question. Why do they bond? Why do atoms undergo bonding? What's the whole reason of atoms undergoing bonding? The reason is that they undergo bonding so that they can be what? Stable. So the reason is to be what? To be stable. So if a question comes in an exam saying, why do atoms undergo chemical bonding? The reason is very simple. It's so that they can be what? Stable. So the reason is to be stable. The reason why atoms undergo bonding is so that they can be what? Stable. So that they can be stable. So now we are talking about chemical bonding. So under chemical bonding, we also have noble gases. Have you seen? So I want us to talk about the noble gases before we go any further. Noble gases. So you discover that noble gases do not undergo bonding. Why? Because they are stable. This is the reason. Because they are what? They are stable. They don't need to undergo any kind of bonding for them to be stable because they are stable on their own. In other words, they have got full electrons in their outermost shell. So you discover that noble gases, all the noble gases have got 8 electrons in their outermost shell except helium. Except what? Except helium. So except helium. Why? Because helium has got 2 electrons in its outermost shell. And because it has 2 electrons in its outermost shell, it obeys Joubre's law. Have you seen? It obeys this law. So any electron or any element that has got 2 electrons in its outermost shell, when it is stable, then we discover that it is having 2 electrons in its outermost shell, which means it obeys this law. So among the noble gases, only helium has got 2 electrons in its outermost shell. Since it has 2 electrons in its outermost shell, then it obeys Joubre's law. But all other atoms that has got 8 electrons All the remaining ones have got 8 electrons in their outermost shell, meaning they obey the octet rule. Have you seen? So when an element has got 8 electrons in its outermost shell and it is stable, meaning it is obeying octet rule. But if it is having 2 electrons in its outermost shell, meaning it is obeying Joubrecht's law. This is what you need to know. This is what you need to understand. So when we look at the structure of a noble gas, so when we look at the structure of a noble gas, we have helium. So you know that helium, the symbol of helium is like this, H small letter E. So then, what is the electronic configuration? It is just 2. Have you seen? It has only 2 electrons. Then we go to another one, which is neon. So what is the symbol Ne? Capital letter N, small letter E. Electronic configuration 2, 8. This is the what? Electronic configuration. Then we go to the other one, which is argon. Have you seen the way I'm writing this? Argon, the symbol is A, small letter R like this. Electronic configuration is like this. So I'm showing you how electrons have been filled in shells. So this one only has 2 electrons. This one has how many electrons? 10 electrons. This one has 18 electrons. So this is the structure. These are structures of noble gases. This is what you need to know and understand. So noble gases do not undergo bonding because they are stable. This is the reason why they don't undergo any bonding, because they are stable. They don't need to react with other electrons or with other atoms for them to be stable. No. They are stable on their own, the way they are. As you can see, this one is 2. There's no other shell that we can put electrons so that it can be stable. This one, they are stable just like that. So now, let us proceed and talk about our main aim, which is chemical bonding. So we go to types of bonding. Let us talk about types of bonding. Let us talk about types of bonding. So you need to understand these types of what? Types of bonding. Types of bonding. So in general, we only have 3 types of bonding at your level. So what you need to understand is that we only have 3 types of bonding. The first one is called ionic bonding. Hope these are not new. We are able to revise through. Ionic bonding. Second one is called covalent bonding. Covalent bonding. The third one is called metallic bonding. It's called metallic bonding. So, as you get to improve in your academic journey, you are going to talk about other types of bonding, because we don't only have 3 types of bonding at an advanced level. We have more than 5 types of bonding. But at your level, you just need to know these 3 types of bonding, which is ionic bonding, covalent bonding, and metallic bonding. These are the only 3 types that you need to consider or talk about. So now I'm going to start with ionic bonding. This is the first one that we are going to start, the ionic bonding. So the other name for ionic bonding, some books will not talk about they will not use this word ionic bonding, but they will prefer using this word, which is electrovalent bonding. Have you seen? So make sure you know this word. It is what? Electrovalent bonding. So electrovalent bonding and ionic bonding, they are just the same. So if you want, you can be using this term. If you want, you can be using that other term. They are just the same. These are just the same. So what is ionic bonding, or what is electrovalent bonding? So this is the transferring, just need to know that this is the what? Transferring of electrons. See, just the transferring of electrons from a metal to a non-metal. I want you to get this. This is just the transferring of electrons from a metal to a non-metal. So electrons are being transferred from a metal to a non-metal, which means that this is a type of bonding that exists between metals and non-metals. So if a question comes in an exam where they are telling you that give a name of a type of a bond that exists between a metal and a non-metal, we call that as an ionic bond. So this is a bond that exists between metals and non-metals. It is called an ionic bond. Then you know that in this, we know that for a metal to be stable, it will lose electrons. And for a non-metal to be stable, it will gain electrons. So an example of this, we can get a metal like sodium. We get sodium like this. We also get a non-metal like chlorine. So you know that this one, sodium, is in group 1 of the periodic table, which means that it has 1 electron in its outermost shell. So since it has 1 electron, so it will lose that electron for it to be stable. So when it loses that electron, it will gain a positive charge. Have you seen? Then we know that chlorine is in group 7 of the periodic table, which means that it has 7 electrons in its outermost shell. So for chlorine to be stable, it will gain 1 electron. So gaining 1 electron, it will enable chlorine to attract a negative charge. So have you seen these are metals having positive charges, non-metals having negative charges. So when these two combine together, this one comes there, this one, we get the valences 1, 1. So when they combine, we form what? Sodium chloride. So when you look at sodium chloride, this is a bond between a metal and a non-metal. So we can call this as an ionic what? An ionic bond. We can call this as an ionic bond. We can call it as an ionic bond because it is existing between a metal and a non-metal. So this process of losing or gaining of electron, there is a specific term that we call them. This term is called electrovalence. So it is called electrovalence. Have you seen? Electrovalence. So what is electrovalence? You need to know what electrovalence is. What is electrovalence? So electrovalence is very simple. Electrovalence is a what? Is just the number of electrons that an element will lose or gain for it to be what? For it to be stable. It is called electrovalence. So it's just the number of electrons lost or gained in the process of forming what? Bonds. So this is electrovalent. So electrovalent, I've told you this, the number of electrons that an element will lose or gain. So just the lost or gained electrons. So there is also same term, but we say electrovalent now. Electrovalent what? Electrovalent compound. So, or electrovalent. What is electrovalent? So, an electrovalent bond, this is a bond of attraction. So, this is just a bond of attraction between oppositely charged ions. So whenever you are talking about electrovalent bonds, electrovalent bond, this is what I've told you, that this is an ionic bond. So this is an ionic bond. This is an ionic bond between what? Between oppositely charged ions. Have you seen? So an ionic valent and electrovalent bond. This is a bond that is between what? Positively and negatively charged ion. In other words, oppositely. I used this word called oppositely. So oppositely charged ion, oppositely charged ions, charged ions. This is what I said. So an electrovalent bond. This is an ionic bond between oppositely charged ions. So we are talking about negative charges and positive charges between a metal and a non-metal. This is what you need to understand. So we've got an ionic bond. What is an ionic bond? If someone asks you a question, what is an ionic bond? So what you need to know is that an ionic bond, an ionic compound, sorry. So an ionic compound, this is a compound that contains cations and anions. So this is what you need to get. So now, what are some of the examples of this type of bonding, which is ionic bonding? So some of the examples that we can talk about, we've got sodium chloride. So we can talk of sodium chloride. We can also talk of magnesium oxide. We can also talk of calcium chloride. These are examples that, just to list a few. Any compound that exists between a metal and a non-metal, it is called an ionic compound. So we've got sodium chloride, magnesium oxide, calcium chloride. This is what we need to know. These are some of the examples that you need to consider. So now, I'm going to teach you how we can form these compounds. So these are examples of ionic bonds. These between a metal and a non-metal. So these are just a few that we need to understand. So we've got this one, which is sodium chloride, magnesium oxide, calcium chloride. These are just a few that we need to consider. So now let us now talk about formation of these bonds. So I'm going to start with formation of what? Formation of sodium chloride. So formation of sodium chloride. How can this be formed? So formation of sodium chloride. How can sodium chloride be formed? So formation of sodium chloride. So sodium chloride is like this. This is sodium like this. So I'm going to write the atom of sodium. I know that when I check on the periodic table, sodium is having 11 there and 23 there. Have you seen? But what is more important is this one. This is what is more important. So I'll just concentrate on that. Then I've got a chlorine here. I've got a chlorine here having what? 17 there and 35.5 like that. So this is called proton number. This is called a mass number. This is called proton number, mass number. Have you seen? So when writing the electronic configuration, so this is called the proton number. This is called the mass number. So the other name for mass number is called the neutron number. And the other name for proton number is called the atomic what? Atomic number. This is what you need to get and understand. So I want you to get this. So what is the structure? How can we write the structure of this? You know that this is what? This is sodium. I'm going to do this. This is what? Sodium. So since it is sodium, I'm going to put first. I know that the electronic configuration of this will be what? First here I'm going to have 2. Second 8. Then third 1 like this. Have you seen? So this is the electronic configuration of sodium. So I'm going to have how many electrons? I'm going to have, so I'm going to have how many electrons? In the first shell here, let me put this first shell here. I'm going to have 2 electrons. So I do this, I do that. The second shell, I'm going to have 8 electrons. So I put 2 here, I put 2 there, I put 2 there, I put 2 there, I put a 2 there, I also put a 2 there. Then in the third shell, I'm going to have how many electrons? 1. According to the electron configuration that I wrote there. So I'm going to have 1 electron. This is what I need to do. So when this is what? Sodium. This is the structure of sodium. I go to chlorine. What is the electronic configuration of chlorine? So first shell, I need to have 2. Second, it is 8. Then third, it is 7. So when you add this, you discover that you've got a 17. So this is what we get to follow. You know that in the first shell, we need to have 2 electrons. Second shell, we need to have 8 electrons, a maximum of 8 electrons. So, which means that chlorine will be like this. This is chlorine. I'll do this. First shell, I'm going to put how many electrons? 2. So I'm going to put these crosses to differentiate this. This other one, how many electrons am I going to have? 8. So I put 8, 4, 5, 6, 7, 8, like that. This other one, how many electrons? The last one, how many electrons? 7 electrons. This is what I'm going to do. So 7 like that. Even here like this. 6, then a 7 there. So these are 2 what? These are 2 elements or 2 atoms that I'm having. These are 2 atoms that I'm having. So now I want to form a bond, which is an ionic bond of sodium chloride. So I know that a metal loses electrons, which means that this metal will lose electron to this one. Have you seen? Then chlorine will gain electrons. What will happen? So what you need to do now is when this one goes there, then this one would, since it is having 8 electrons in its outermost shell, 7, it is having 7 electrons in its outermost shell, meaning it will gain 1. Then this one will lose. Then what we are going to form by the end of the day, this is what we are going to form. So this one, since it is losing 1 electron in its outermost shell, and we are having 1 electron, so this outermost shell will be removed. We are going to have sodium like this. Then I'll put this one like this. Have you seen? Then 2 electrons. The next, this other one having 8 electrons like this. Since that one has been lost, the one, then I'm going to put this. I'm going to do this. Then since it has lost how many electrons? It has lost 1 electron. So I'm going to put a plus there. Then I'm going to do this. Open. Then I draw now this one now, which has gained 1. So it is having 1, 2, 3 electrons. Have you seen? 3 shells. So I'm going to say this is chlorine. I'm going to do this. First shell, I'll put how many? 2, like this. Second shell, I put how many? 8. So I'm going to put 8 like this. 8. So hope you are able to see what is happening. Even this one here, I'm going to put 8 because it has gained another one. So I can wrap this up. We've gotten the concept. So I'm going to wrap that one there. So 8 electrons, even there, here 2, here. Then it has gained 1. Then I'm going to do this. Then I'm going to put a negative showing that it has gained 1 electron. So this is what you need to do. So this is a structure that you need to form. This is a structure that we need to form. So this is how we get to answer these. This is how we get to form these ionic compounds. So now let me now give you the last example how we can form this one that is having a 2 here, which is calcium chloride. So forming calcium chloride. How can we form calcium chloride? I'm going to do this. So just going to love this part, this part here. So we are forming what? We are forming calcium. This is what we want to form. Calcium chloride. Then we know that it is like this. Have you seen? This is what we want to form. We want to form what? Calcium chloride. So how can we form calcium chloride? As you can see, we are having two atoms of what? Two atoms of chlorine. So which means that we are going to have a chlorine this side, then calcium, then chlorine. So two atoms of chlorine are surrounding what? Are surrounding calcium, which is here. Have you seen? This is what you need to do. So which means the way I've presented them like this is how I'm going to write them. So I put the structure for chlorine this side, structure for calcium, structure for chlorine this other side. Because there are two there. So if there are three, one would have been here like this. Have you seen? But since there are two, this is how I'm going to write them like this. So I'm going to put chlorine this side. So you know that the electronic configuration for chlorine, we've just from doing it, it is what? 2, 8, and 7. This is electronic configuration. Then calcium. Calcium electronic configuration, you know that calcium is like this, just got a 20 there. So this is 2, 8, 8, and a 2. So this is how electrons are going to be. Have you seen? Even this one. So I'm going to put these diagrams. So I'm going to start with chlorine here. So I'm going to start with chlorine here. So I'm going to do this. First shell, I put 2. Second shell, I put what? I'm following that. I put 8. So I put 8 like this. Put 8. Third one, I put 7. I'm going to put 7. So this is what I'm going to do. I put there like that. Even here, I do that. There, there. Even here, I'm going to do that. Then I go to calcium. I'm going to put calcium here. So calcium is having, like here, calcium is having 4 electrons, 4 shells. So I'm going to write it here because of space. So first one, to differentiate these, I put crosses. First 2, I put 8 there. 4, 6, 8. Even this other one, I put how many? I put 8. I'm following this electron configuration like this. This is what I'm going to follow. Then this other one, I put how many? I just need to put how many? Just needs to put how many? I put 2. So this one will be this other side. The other one will be this other side. I know that this one will be roast to that one. Even this one will be roast to that other one. So here I put now chlorine. The same chlorine that is this side, I put it this other side. So I say chlorine here. So first shell I follow those like this 2. Second 8. Second shell I put 8 like that. This is how I'm going to do. Then the last one I put how many? I put 7. 2, 4, 6, 7 like this. So this is what I've formed. Have you seen? This is what I've formed. So now I know that this one is a metal. This is a metal. So this one will do what? Lose electrons. 2. To lose calcium loses 2 electrons. So this one will go there. This other one will also go there. Have you seen? So which means that this one will be full. Then I'm going to do this. I'm going to put chlorine this side. Then I'm going to do this. 2 electrons like this. Then I'm going to, this one is having 8 electrons. So 8 electrons like this. This other one also is having how many electrons? 8. It has gained 1. So this is what you are going to form. You do this. This is what we are going to form. Even here, it has gained 1 from calcium. Then I do this. I put them in brackets. Since it has gained 1, so it have a negative charge. Then I'm going to do this. I put calcium. Calcium, it has lost 2 electrons. So I'm going to say this is calcium. First shell having how many? So 2. Second shell having how many? 8. So I put 8 there. 8. Then the third shell, I'm going to have how many? 8, this one. The fourth one has been lost because it has lost 2 electrons that were there. Like this, I do this. Then I put what? What am I going to put? I'm going to put here a 2 plus because it has lost 2 what? 2 electrons. So I'm going to put a 2 plus. Then I put another chlorine this side. Have you seen? So I put another chlorine this side. Even the one that is this side has done what? Has gained 1 electron like this. Here 8. I do this. I put 8. Have you seen? Like this. Even this one here, I'm going to put 8. So a star, then showing that this one just came from somewhere. Like this. They are full now. I do this. Then I say minus here. Have you seen? So this is the structure for what? For calcium chloride. So when you are taught, this one usually come in an exam. So make sure you understand this part. This will really help you. So make sure, have you seen the way I've written? This, like this, starting from this one. Chlorine, this is calcium, this is chlorine like this. This is how you need to write them. Have you seen? So maybe someone is wondering, calcium here, then I put it like this. So this is not a shell, we don't count it. Start counting from there like that. Have you seen? Like this. These charges on top are very important, so you need to make sure that you show those charges. Those charges are very important. So now, this is all that you need to know under ionic bonding. Let us now move to covalent bonding. So before we move to covalent bonding, you need to know certain characteristics of ionic compounds. So you need to know the characteristics of these compounds. So what are some of the characteristics of these compounds, which are ionic compounds? So they may ask you in an exam. So what are these characteristics? So let us talk about these characteristics. So the first characteristic that we are going to understand is that these are made up of, so they are made up of positively, so they are made up of positively and, so positively and negatively charged. Positive and negatively charged. So they are made up of positively and negatively charged ions. Second one is that they are what? They have got high melting, and boiling point. High melting and boiling point. This is what you need to understand. High melting and boiling point. Like this. So they may ask you, why is it that they have got high melting and boiling point? Is because they are made up of strong electrostatic forces of attraction between them. This is the reason why they have got high melting and high boiling point, is because they are made up of strong electrostatic forces of attraction between them. So we've also have the third one that we are going to talk about, is that they are soluble. So they are what? They are soluble in water. So these are soluble in water. Soluble in water, but insoluble. So but insoluble in organic. So insoluble in organic. This is organic. So organic solvents. Organic solvents, we talk of petrol. Have you seen? So talking of petrol, this is an example of an organic solvent. We are talking about what? Petrol. So we're talking of petrol, ethanol. So they are insoluble in those solvents. Then the fourth one that we can talk about is that they conduct electricity. So I won't write this one. You can write it down. They conduct electricity in molten state. If they ask you why is it that they have got high rate of conductivity, electric conductivity, is because they are made up of mobile electrons. So the reason why these conduct electricity, it is because they are made up of what? Mobile electrons. So they conduct electricity. They conduct electricity in molten state. Conduct electricity in what? Molten state. Or in aqueous state. Have you seen like this? This is what you need to know and understand. So now let us move to the other type. We move to the other type. Let us move to the other type now. The other type of bonding. Hope you've understood this one. If question comes in an exam, you are able to answer. So let us now look at another type of bonding. So we move to the second type of bonding. So make sure you've subscribed to this YouTube channel and make sure you share this video with your friends. You share with your friends, schoolmates, with everyone, your colleagues, anyone. You share this video, this YouTube channel with everyone that you know, so that we get to learn together. So let us now talk about covalent bonding. So what is covalent bonding? What is covalent bonding? This one also has got another term. So apart from covalent bonding, we can call this as molecular. So you can call that as molecular bonding. Have you seen? So this is what you need to know. You can call it as molecular bonding, just one and the same. So when I'm talking about molecular bonding or covalent bonding, it's just one and the same thing. So now, what is molecular bonding or what is covalent bonding? So covalent bonding, so I'm going to say the definition of this one. This is just the sharing, this is what you need to understand. Sharing of electrons. So this is just the sharing of electrons. So it is the sharing of electrons. This is just the sharing of electrons between non-metals. So sharing of electrons between non-metals. So this is what you need to get. This is the sharing of electrons between non-metals. The sharing of electrons between what? Between non-metals. So each time we are talking about covalent bonding, this is just the other name is what? Molecular bonding. What's the definition? Sharing of electrons between non-metals. So this is just the sharing of electrons between non-metals. So now you need to know when we say, what if I say, what is a covalence? Have you seen what is a covalence? So a covalence, this is what? The number of electrons an atom shares shares with another atoms. So what is a covalence? Covalence, this is just a what? A number of electrons. So this is just a number of electrons that an atom shares with other atoms. That is what? Covalence. This is what you need to understand. So covalence is a number of electrons that an atom shares with other what? Other atoms. Then there is what we call a covalent now. Is what we call a covalent bond. So what is a covalent bond? What is a covalent bond? A covalent bond is very simple. So the other name, since there we said covalent bonding, the other name is what? Molecular bonding. So if we are talking about covalent bond, we are talking about what? Molecular bond. Molecular what? Molecular bond. So what is molecular bond? What is molecular bond? So molecular bond A molecular bond, this is a bond of shared pair of electrons, and this is formed between non-metals. Have you seen? So this is what? This is just a bond of shared electrons. This is what you need to get. This is just a what? This is just a bond. We are just talking about a bond of shared. So a bond of shared, hope you are able to see. This is shared, a bond of shared electrons. So this is a bond of shared what? Electrons. This is just a bond of shared electrons, and it is formed between non-metals. So whenever we are talking about molecular compounds, molecular bonds, these are just molecules. Have you seen? So usually molecular compounds. So when you are talking about molecular, as you can see, molecular what? Molecular compound. So molecular compound, usually we are just talking about what? We are just talking about molecules. Have you seen? We are just talking about what? Molecules. Then you know what molecules are. Molecules, these are a group of atoms that exist independently, and they are free, they are in free state. Have you seen? So this is what you need to understand each time we are talking about molecular compounds. So you know that a molecule is just these are atoms that exist independently, they are in free state. So each time you're talking about covalent bonding, so you need now to understand the examples of these compounds. So what are some of the examples that we need to consider? What are some of the examples that we need to talk about? So examples of what? These are examples of covalent bonding. Have you seen examples of covalent what? Bonding. Examples of covalent bonding. So what are some of the examples of this covalent bonding? We've got the hydrogen molecule. So hydrogen molecule is like this. We've got hydrogen molecule. We also have H2O. We all know that this is water. We also have ammonia. We know that ammonia is like this. We also have oxygen molecule. So these are just some of the examples that we need to consider. So these are some of the examples that you need to know under covalent bonding. So we've got the hydrogen molecule, we've got the water molecule, we've got the ammonia, we also have oxygen molecule. So these are examples. So I'm going to show you how we can now form this. So each time you are talking about covalent bonding, we just concentrate on the outermost shell. So we just talk about the outermost shell. We just need to understand the outermost shell. So we can start with anything here. So let us start with water. Let us start with the water. So how can we form this bond? So how can we form that? So I'm going to lab this part. Hope you are able to understand everything that I'm trying to illustrate here. So let us now start with what? Formation. So we are going to talk about formation. Formation of what? Formation of water, which is H2O, like this. This is what we are going to talk about. So in an exam, they won't tell you that this is an ionic compound, this is a covalent compound. No, you need to know what they are really talking about. So how can you form this? So I've told you that what you need to consider is the outermost shell. So you know that water is formed by two elements, which is hydrogen and oxygen. So you know that hydrogen is like this. This is the way hydrogen is. Hydrogen only has one electron. So like this, one electron. Have you seen? So it is H2O. So it means two atoms of hydrogen are surrounding oxygen. So it is like this, HOH. Have you seen? This is how we need to get that. So two atoms of hydrogen are surrounding what? Oxygen. Here and this other side. So I've told you that we only talk about the word outermost shell. You go to oxygen. So here I need to put oxygen here. So oxygen has got how many electrons in its outermost shell? Oxygen is like this. There is 8 here and a 16 there. So electronic configuration is like this, 2 then a 6. So it means it is having 6 electrons in its outermost shell. So I'm going to get these 6 electrons. So just talk about the 6 electrons. So I'm going to do this. Have you seen? So I'm going to say here 2. To differentiate, I put crosses 2, 4. Then I put 5 here and a 6 there. So there are 6. Then I put another what? I put another hydrogen this other side. Then you know that hydrogen has only 1 electron in its outermost shell, like that. So 1 electron in its outermost shell. So I've told you that this is the what? This is the sharing. It is the sharing of electrons. So electrons are not transferred, but they are shared. So they are doing what? They are sharing. So sharing, so it means here they are going to share this one. So that they can be stable. Even these, they are going to share here. Have you seen? So when this shared, which means that they are going to form something that will look like this. This is what we are going to form, like this. This is what we are going to form. So we are going to have hydrogen this side, oxygen here, hydrogen this other side. So they have got 2, even they have got 2. Have you seen? So these are being shared. So these which are being shared, I'm going to write them here. Have you seen? These are electrons that are being shared. So this is a what? A compound. This is a structure for water. Have you seen? So as you can see, oxygen must have 8 electrons in its outermost shell for it to be full. If you count these 1, 2, 3, 4, 5, 6, 7, 8, there are many. There are 8 electrons. Even hydrogen needs 1 electron. So and it is here 1. It has gained 1. So if you count here, we are having 2. If we count there, we are having 2. So this is how these bonds are being formed. This is what you need to understand. They are just being shared there. Have you seen? They are just being shared there. So this is the what? The structure for water. This is what you need to get and understand. So I want you to understand this. You get the concept. You get what I'm trying to illustrate here. So now, let us look at another example. So hope you've seen how this one is. This is what you need to form. So let us look at another type. So we talked about formation of water. Let us now form ammonia. So how can you form ammonia? Let us talk about this. So if you are watching this, you can pause this. You can pause a video, then compare your answer with my answer, how I'm going to form this. So make sure you pause the video, then you try to answer this one. Try to work out this and see how you are going to form. If you've understood the concept or you are still learning. So try this one, pause this, then pause the video, then try to continue how you are going to answer it, because this is a bit simple compared to these other ones. So what you need to get now is that you're having 3 atoms of what? Hydrogen surrounding what? Nitrogen. So this, you can write this as nitrogen here, then hydrogen this side, hydrogen this side, even hydrogen down. If you want, you can put it down or you can put it on top. So this is what we are going to do. So you know now that hydrogen, whenever we are talking about covalent bonds, we are just talking about the outermost shell. So our key interest is in the outermost shell. So we just focus on the what? Outermost shell. So we just need to focus on the outermost shell. So the outermost shell of hydrogen, you know that hydrogen has only 1 electron in its outermost shell. Then nitrogen is like this. The proton number is 7, then the mass number is 14. So when we write the electronic configuration, we are going to have 2, what? 2,5. So how many electrons are there? 5 electrons. So these are the 5 electrons. Then, so you need to be writing this, you need to be as smart as you can, because you know that, okay, three of the elements, or 3 of the electrons of nitrogen are going to be shared to this. So you know that 3 electrons, you need to put them separate on their own. So we are going to start with what? We are going to start with hydrogen. So hydrogen 1 there. I go to nitrogen here. Nitrogen has got 5. So 1 this side, 1 this other side, 1 here. Because these are electrons that are going to involve themselves in bonding. Then the 2, you put them there. If you count these, there are many 5. So you don't just write this anyhow. You write this as smart as you can. So you need to be very smart and sharp. So this is how you need to do it. Then you put another hydrogen this side, like this. So this is not a shell. Remember, this is not a shell. So you do that. Then you put another one here, like this. Then you say, this is hydrogen here. You put hydrogen here. Have you seen? Hydrogen there. Then it is having 1. So you know that the electrons that are going to be shared, are these. 1, 2, how many? 3, like this. So you know that hydrogen must have 2 electrons in its outermost shell. Then this one must have 8 electrons in its outermost shell. So this is what you need to get and understand. So what I'm going to follow now, this is what I'm going to follow. So these are going to be shared. So which means the one structure that I'm going to form when these share, the structure will look like this. This is how the structure is going to be. So hydrogen, nitrogen, hydrogen, hydrogen, like this. So you know that this is nitrogen, this is hydrogen, even this side we've got hydrogen, even this other side we've got what? Hydrogen. So these are going to share, these are going to share this. So they are going to form as one, they are going to be put in one space. Where? Here, like this. Even here, this. Even there, like that. Have you seen? These are sharing, these 2 are sharing. Even the 2 here are sharing, even the 2 here are sharing. So I put these ones there, like that. So this is a what? This is a structure for what? Ammonia. So get this. This is the structure for what? Ammonia. So this is the structure for ammonia. Make sure you get this, you understand this. This is ammonia. Have you seen ammonia is like this? NH3. This is ammonia. So make sure you understand this. So these are so at your own time, you can go through some questions. You try to go through some questions, you practice them. So this is just what I want you to write. So let me just give you some. So these, they can be a combination of, it's you now to decide. You are going to know if it is ionic or covalent bonding from the knowledge that I've taught you. So I want you to write the structural formula of this. So this is the knowledge that you have, what you've gathered, or from what you've learned from this. I want you to answer this. So I want you to write the structure formula of, structure formula of magnesium oxide. This is the first one. I want you to write the structure of, this one. This is called methane. Have you seen? This is called methane. This is methane. I want you to write the structure of oxygen molecule. So you are going to know which ones are covalent bonds, which one are ionic bonds. So I want you to get this, and I want you to write this. So this is what you need to do at your own free time. So go through this, write the structure, this the same way I was writing the structures of the other ones. I want you to write the structures of these ones. So this is very simple. This is very simple. We are able to do that one. So now let us look at now characteristics. Then we conclude. Let us look at the characteristics. So this is your work. So let us look at the characteristics now. So we look at the what? The characteristics. How is the character of this? So we look at the what? Characteristics. So I want us to look at the characteristics of this. So what are some of the characteristics of this? So the first one that we are going to talk about, how are these? These, one thing you need to know is that they are made up of molecules. So these are made up of what? Molecules. They are made up of molecules. Second one is that they have low melting. So they have low melting and boiling point. So just the opposite of those. Low melting and boiling point. These are what you need to understand. The third one is that they are generally, so these terms are very simple for you to know. So volatile. Have you seen? They are generally volatile. The fourth one that we are going to talk about is that they usually ask these in an exam. So make sure you understand. So these are insoluble. So these are insoluble in water, but soluble. But what? Soluble in organic. So soluble in organic solvents. So I told you what organic solvents are. Petrol, we've got petrol, ethanol. Those are examples that you need to get. So those are some of the examples that you need to know and understand. So make sure that you understand all these principles that I've told you. So now, then the last one, which we don't even, they don't even ask of it mostly in an exam. So this one, they don't usually ask it in an exam. But since we are doing bonding, I'm going to illustrate something. We are going to talk about something also. So the last one, the last type. So the last type is what? Metallic bonding. So the last one is metallic bonding. So this is the last one, which is what? Metallic bonding. So this is metallic bonding. So this is the last one. So metallic bonding, you know that this is a type of a bond that exists between metals. So it only exists between what? Between metals. So metallic bonding is the what? Is the attraction between positively charged metal ions and the free electrons that are in a metallic lattice. This is what you just need to understand on this. So you know that the electrons that are in a metallic lattice, they are free to move. They are free to move in a what? Lattice, like this. Have you seen? So let's say we are talking about the lattice of what? Sodium. So if this is sodium, you know that you are going to have positive, negative, negative, just like that. Positive, negative, negative, just like that. We are talking about something like this. Have you seen? Something that is like this. This is what we are actually talking about. So here now you discover that electrons are free to move. Whenever I'm talking about electrons, you know that electrons are negative. These are electrons. Have you seen? Then sodium, you know that sodium is positive. These are positives. Have you seen? So these are just bonds that exist between what? Between metals. They just exist between metals like this. This is a what? A lattice. So electrons are free to move. So what you need to know, the more we've got atoms of sodium in this, the more electrons are going to move. So the more atoms are, the more electrons are going to do what? The more electrons are going to move. This is what you need to get and understand. We are going to have more movement. Have you seen? This is what you need to get and understand. So make sure you get this part, you understand this principle very well. So this is all about what? Metallic bonding. This is a attraction between the positively charged metal ion and free moving electrons in a metallic lattice. And you know that in a metallic lattice, we've got electrons free to move in a lattice. They are free to move. Have you seen? So this is what you need to get. This is very simple. I know you've understood. So if you are looking now for tuitions, you can, I usually conduct tuitions. So you can contact me on this line. This is my line. You can contact me on this. This is the line you can use to contact me. This is my contact. So you can contact me on this line. +2609710666747. This is a line you can contact me on. You can call me, you can WhatsApp me. It is also on WhatsApp. 0971 Thank you so much. Make sure you subscribe to this YouTube channel.